Hello, I'm Joe Manieri, and today I'm going to talk about the research that I conducted this semester, which I've entitled Stealing Corporate Data Undetected, a DNS Covert Channel. Now what this research shows is that even when we use DNS in an RFC compliant manner, we can still use it to send commands to and receive exfiltrated data from a PC that's protected by a modern security infrastructure. And here's how we did it. First, our presupposition is that, of course, we have an infected PC on the inside of this network, and then second, that we control an evil domain name server somewhere on the internet. The command that we would like to have executed, we encrypt with a shared secret and then base 64 encode it, and then take that encoded ciphertext and store it as a data portion of a TXT record. Our PC periodically wakes up, polls for that TXT record, and eventually receives our command, which it decrypts and decodes and then executes. Now in our case, we would like to steal a sensitive document. That document is located, it's broken into blocks, each block is encrypted with the shared secret, and then base 32 encoded. Those base 32 encoded blocks then become the hostname portion of DNS queries. Those DNS queries come back through the infrastructure and eventually make it to our evil domain name server, and all of those queries are recorded in that evil server's query log, which can then easily be reassembled and decoded to restore the sensitive document. We use a wildcard entry in our DNS record so that each query actually returns an address rather than an NX domain error message, which might generate some suspicion. Let's take a quick look at the evidence that was then left by the security devices in our infrastructure and see how could we detect this. First, we note our corporate infrastructure name server, which, while the records are in the query log of this data that was exfiltrated, we see that it looks very similar to legitimate traffic. In this case, we have a cloud service that has names that look just like our exfiltrated data names. So simply looking for hostname entropy or some other strange looking names really is ineffective to detect this. Our anomaly detection system, while we do see a spike here in the traffic as it left, it's not a spike that's big enough to actually generate an alert or have any notice by our analysts. Our next generation firewall, which is able to decode applications and understand protocols, simply classifies all this activity as DNS and lumps it together with all DNS traffic. The individual events related to our exfiltration show up again just as traffic, not as threats or alerts in any way. And finally, our network intrusion detection system, the only signature that goes off as a result of our exfiltration, you see, is the DNS query signature, and all of our exfiltrated data is lumped in with 49,000 other DNS queries that were going on at roughly the same time. So while there was evidence that this exfiltration took place, no alarms were generated, no analysts took notice, and we stole the data in an undetected manner. So what can we do for this? Well, there's techniques that we use in both web content filtering and anti-spam technology that if we could employ those with DNS, we might have a way to stop these kinds of activities from happening. First, we can use reputation services. In this case, domains with bad reputations for some reason simply would not be resolvable. Second, we can use DNS black hole technology, again built into named or bind itself. And in this case, hosts that are known to be malicious, again, simply aren't resolvable. And finally, domain name categorization schemes. Similar to what we do with web content, administrators would be able to subscribe to the kinds of domains that they would like to be resolvable in their environment, and all of those would be unresolvable. So if we had techniques like this, we could then have some methods to either detect or thwart these kind of attacks and stop exfiltrated data using DNS. Thank you.